All right, hello everyone. Today we are going to be talking about frequency distributions, but we're going to talk about the spread of the data values. And I'm going to start that with an example just to kind of help you understand what we are talking about. Imagine customers waiting in line for tellers at two different banks. Customers at Big Bank can enter any one of three different lines leading to three different tellers. Best Bank also has three tellers, but all customers wait in single lines and are called to the next available teller. The following values are waiting times in minutes for 11 customers at each bank. The times are arranged in the following order, so ascending order. So here's what you have. You have Big Bank, that's where they had three lines. So picture when you walk into the bank, you can choose one of three lines while you wait for the teller. It's not the next teller, it's the teller on your line. Best Bank is having everyone form one line while you have to wait for the next available teller. These are the times that they waited according to which type of line that was formed. This is the graphs of those. So look here. Big Bank, which had the three different lines, these were the waiting times for those, that three lines. This is Best Bank, which would had one line, and you can see the wait time on average here. So the difference in customer satisfaction comes from the variation in waiting times at the two banks. You can see the distribution. This has a bigger spread of times, whereas this has a smaller spread. They're all within a certain amount of time, closer together. Whereas this one, you could wait anywhere from, there was 3 and something, all the way up to over 11 minutes. And this is what we kind of talk about when we're talking about the spread of the data. Range. Now let's talk about range. And we're going to get more into the spread when we get into standard deviation, but one type of spread is your range. And that's just the difference. This is a very easy calculation, I promise. It's just the difference between the highest and the lowest value in your data set. It indicates the total spread of the data. So range is just the highest value minus the lowest. For example, if you look at these numbers, you have to find your highest number. So here that would be the 93, and the lowest number would be 12. The range would be 93 minus 12, which is 81. That's it for the range. So let's go into the standard deviation. The standard deviation measures how much the data differs from the mean. So when you calculate the mean, how much does that data differ from it when we are looking at the graphs and we're doing our calculations? It is the most useful measure of dispersion, since it tells us how each value from the data set differs from the mean. For example, or meaning the distance from the mean. So what is the purpose of the standard deviation? It's to represent an average of the sizes of the individual deviations without regard to their signs. So we're not looking at positive and negative, just their individual deviations. Here are some symbols that we use. Typically, when we're talking about the standard deviation of a sample, we just use S. If we're taking the standard deviation from a population, then we use this Greek symbol called sigma. All right, what is the formula to find the mean? Here is the steps. I'm going to put steps to find the mean. First step, to find the standard deviation. So here are the steps to find the standard deviation. You find the mean. That's the very first step. You have to find the mean of the data set. Then we're going to have a chart, and we're going to do one below, where you're going to have one column data values. The next column, you're going to take the data minus the mean. And then the third column, you're going to square all of the values that you found from the second column. Again, this will make more sense when we jump into an example. The third step, you add, well, first of all, the sum of the second values should always add up to 0. Unless we're rounding, it could be slightly off, but it will be close to 0. Add the values in the third column. That's what we really need. We really need the total values, the total of those values in the third column. Then we're going to divide that total by n minus 1. Remember, n is the number of values in your data set. So you're going to take that minus 1 and then divide. Then, I know we're not done yet. The standard deviation is then going to be the square root of what you found in step 5. Now, I know this sounds like a lot, but when we work through the steps, you'll see it's really not that bad. At least I'm going to say it's not that bad. So technically, let me just show you the formula for standard deviation. Remember when we did the mean, we used this summation symbol, right? So we're looking at the summation of, and then we're going to take the square root. And actually, I'm going to erase that. I need to make that smaller. That was way too big. So when we were talking about the standard deviation, let me put it all inside here. What you're doing is you're taking the summation of every x value when you subtracted it from the mean, or the mean, right? X minus the mean, and then squared it. That's your third column. So what this part right here that I wrote down represents is the total from the third column of our table that we're going to be doing. You divide that by n minus 1, and then you take the square root of that answer. Okay, that's what it looks like as a formula. This is what it looks like as the steps. Now let's actually apply all of that. And I promise you when we do this, you're going to say, okay, it's not as bad as it looked. All right, here's our example. A testing lab wishes to test an experimental brand of outdoor paint to see how long it will last before fading. The testing lab makes 6 gallons of paint to test. The results are in months of how long the paint lasted before it was fading. That's what it's showing you. So in other words, this one lasted 10 months before it started fading, but this one lasted 60 months before it started to fade. That's what these numbers represent. To find the standard deviation, I'm going to scroll this up so we can start doing some work here. What we're going to do here is we're going to put in all of our values from this. Now, you can put them in order or not in order. It really doesn't matter. I'm just going to go ahead and put them in order, but again, you don't have to. With standard deviation, these do not have to be in order. All right, that's the first step. That was easy, right? Just writing down the data values. But now we have to find the mean. I can't do anything yet until we find the mean. Well, remember, the mean is where we add up all of the values in the data set. Ooh, I almost ran out of room. Just made it. And then divide by how many numbers are in the value set. 1, 2, 3, 4, 5, 6. So n is 6. We have 6 numbers in our data set. That means I divide that total by 6. That's going to give me 210 divided by 6, which is 35. So our mean is 35. Next step, I'm going to take each data value and minus the mean. Data minus the mean. So I subtract the mean from every data value. I take 10 minus the mean. That's negative 25. 20 minus the mean. Negative 15. 30 minus the mean. Negative 5. And we just keep doing this for every single data value. And then one more, and that's going to give us 25. Now, what I was saying earlier in the little note is that if you were to add up all of the values in this column, column 2, you get 0. All right, I just wanted to put that. That's just something to note. So you can always kind of double check when you're working through your numbers to see if you made an error, but it should add up to 0. Now, third column. We take every single number we found here in the second column and we square it. And remember, when you square any number, whether it's positive or negative, your answer is always going to be positive. Negative 25 squared is 625. So you will always have positive answers here. 15 squared, 225, negative 15 technically. And we get 25. And then 5 squared is 25. 15 squared is 225. And then 25 squared is 625. You know what? I'm going to take a pause and just go down here for a minute because I want to show you something. A little side note. When you are working with squaring numbers, there is a difference between this and this. And I just want to make a note of that. This first one is saying that you're squaring the 25, but leaving the answer negative, which means this would be negative 625. This is saying you're taking negative 25 times negative 25, which is positive 625. With standard deviation, we are doing the negative. We're multiplying the negative times itself. So I use the parentheses. I just wanted to note that because if you were to put negative 25 squared in some of your scientific calculators, it might say, oh no, that's negative 625, but it's parentheses. That's the difference. Okay, going back to the problem. Now what we have to do is add all of these numbers together. Okay, we want the total. That gives us 1,750. I'm going to continue on, going back to the steps. To find the standard deviation, we're taking the square root of the total we found in column 3, so the 1750, and then divided by n minus 1. Go back here, n is 6. So we're dividing by 6 minus 1. That means we're taking 1750 divided by 5 and taking the square root of that number. Okay, so if you're taking, and you can do this, it's up to you if you're going to do this in one step or if you want to first divide and then I'll just show you what happens when you divide. So this gives me the square root. We want the square root then of 350. So the next step is you would take the square root of that, and let's just round to the nearest tenth. Again, you'll see what the problem asks you to round to, but we're going to just say 18.7. Our standard deviation then of this particular problem is 18.7. So just to explain a little bit what this means with this particular data set is think of the average as the center of the data, right? The mean is like the center of the data. The standard deviation tells us how spread out the data are around that center. So in this particular example, the standard deviation was 18.7 months. Which indicates a fairly large amount of variation in how long the paint lasted before fading. Some cans then faded much sooner than average, while others lasted much longer than average. And so we have what we consider a larger variation in this particular case. And in other cases, we might find a smaller variation where the numbers aren't varying too much from the mean of the data set. All right, I'm going to end here because then we're going to move on to an example. So I'm going to end with this example, and then let's move on to a different example. And I'm going to show you, well, first let me tell you about the range of thumb. The standard deviation is approximately, and we put approximately, it's not exact, tends to be the range divided by 4 as a rule of thumb. So I just wanted to put that there to give you an idea. If you had the range, divide that by 4 and just see how far you are or how close you are. But like I said, it's not an exact. but it's just a rule of thumb. But I want to jump down here. I want to show you an example. And then I'm going to show you a calculator. So let me just read the example first. A small animal veterinarian reviews her records for the day and notes that she has seen 8 dogs and 8 cats with the following weights. So you have the dogs' weights and then you have the cats' weights. Now, before we do anything, let's just look at part A, which just says, before we analyze these data sets, let's make a conjecture about which set has the larger mean, median, and standard deviation. And then we'll kind of talk about why. Look at these averages first. We're going to look at these numbers. Now look at the dog weights compared to the cat weights. If you were to find the mean, right, the average of the dog weights compared to the mean of the cat weights, what would we expect? Well, we would expect that the mean of the dog weights is, of course, going to be higher than the mean of the cat weights, because we can clearly see here that the cat weights are much smaller than the dog weights. So that's one thing we could say without doing anything yet, just little conjectures we're making. Now, because the median also we would consider to be higher for the dogs, because again, we have higher values than we do for the cat value. So again, we're going to think that the median is going to be higher and the mean is going to be higher. What about the standard deviation? Well, we would also consider the standard deviation to be higher for the dogs. Why? Because notice your spread. Your lowest weight here recorded is 16 and the highest weight is 107. So I'm going to expect a larger spread in the data and therefore a larger standard deviation. Notice here the cat weights just go from 3 to 22. So I would expect a smaller spread in comparison to the dogs. Now, this is just from looking at the numbers. We're going to compute the mean and the standard deviation of each set. So let's start with the mean. And from there, we're going to go ahead and work through our numbers. Looking at the dog values. If you want, go ahead and pause the video because I'm going to jump in with the numbers. But to find the mean, you want to add up all of those numbers and then divide by how many numbers we have, which we have 8. I'm going to go ahead and write down that total, but if you want, you can pause and do this. But the mean, if you add up all of those numbers, we get 427 divided by 8. That gives us, and I'm going to round to the nearest tenth. That gives me 53.4. Now I'm going to jump down to the cats. And the mean here, we add up all of those numbers. We get 83. And again, there's 8 of those. So we divide by 8. And we get 10.4. So just as we thought, right, the mean is higher for the dogs than it is for the cats, which makes sense. Now the standard deviation. And at this point, you might get a little upset with me because I have a link, because you know I love calculator.net. This is the calculator I've been using with every video. I love this website. I use it for when I'm shopping around for loans and I'm comparing different interest rates and different loan terms, but I also use it for other things. Standard deviation is on there. So I'm going to go ahead and show you how you can use this. And you might think, why did you not show this for the previous example? But that's because, going back to here, I want you to understand the math, the algebra behind how you calculate the standard deviation before we just jump into using an easy calculator. I want you to understand the math behind it. But now, yes, now I will do it just like we did with the loans. I showed you how to use the formula, and then I jumped in and showed you how, and I just realized I already have it open, how to use the calculator. So if you go to this is calculator.net. All you do, now over here, see the different options between population and sample. Whenever we do this for class, just make sure it's clicked on sample, because all of ours is going to be from a sample. All right, going to here, let me just show you. All you do here is you put in all of the numbers. So going back to those notes, I'm looking at the dogs. There's 8 weights. So 16, and you just put commas between each one. Just see how you see it written in the notes. I'm just writing down all of those dog weights that we had. And I'm hoping I'm putting this in correctly. And then 107. We're about to find out. That's all we do. We put in the numbers and we click calculate. And notice right here, this is all we need. All I need is that number right there, which is 30.1. So that is the standard deviation. Let me go back up to here. And let me just change colors for the standard deviation. So the standard deviation for the dogs is 30.1. Now, going back to the website, and then notice it just kind of shows you everything, the whole formula, right? Very similar to what I showed you. It shows you the formula, it shows you even the numbers, which I love. All right, now I'm going to go back. I'm going to click the back arrow, and I'm going to put in the cats. So the cats, I'm just typing in what I see. Again, hoping I'm not making an error here. 17 and 22. These are the cat weights. I click calculate. This is showing me, if I round to the nearest tenth, a standard deviation of 7.1. So I go back here, and the standard deviation for cats, oops, almost lost my color here, is 7.1. This is as we expected. Not the numbers. We didn't know what the numbers were, but when we were making the conjecture, we said the mean is going to be higher for the dogs, of course, because the weights are more. But we also predicted, I'll say, that the standard deviation for the dogs is going to be bigger, meaning there's more variability, more spread from the mean, more deviation from the mean with the dogs because there's such a spread of the data values, a large spread. With the cats, not as big of a spread, and notice we do have a smaller deviation. And so it was exactly what we thought. And so I wanted to just show you, again, how to do standard deviation, yes, by hand, and then with the calculator, but also what it means when you're looking at the standard deviation. And again, we're talking about the variation from the mean. How spread out is the data? How much are we varying? Do we have a large variation? Do we have a smaller variation? All right, that ends our video for this part. The next video, we're going to touch upon something called the 5-number summary.